Hi guys, in the given question it's been said that there is a cylindrical bucket. The dimensions are given to us. The bucket is filled with sand. This bucket is emptied on the ground and a conical heap of sand is formed. If the height of the conical heap is 24 centimeters, we have to find the radius and the slant height of the heap. So let's say this is our cylindrical bucket over here. This bucket is completely filled with sand. So let's say this is sand inside this bucket. Now this bucket has been emptied out on the ground and a conical heap is formed. When this bucket is emptied out on the ground, you will see a conical heap, something like this would be formed. This is our conical heap. It's completely made up of sand. What we have to find, we have to dimensions of this conical heap. So when the sand has been taken out from this cylindrical container and it's been emptied out, you will see volume of sand that would remain constant, and volume of sand that would be nothing but the volume of this cylindrical bucket which is forming this cone. So volume of the bucket that would be equal to volume of this conical heap. Now about the volume, the dimensions are given to us, so we can easily calculate the volume of this cylindrical bucket. It's 32 centimeters height, so height of the cylinder that's equal to 32 centimeters. Radius of the base R, that's equal to 18 centimeters. For the conical heap, the radius is given to us, that's equal to, height is given to us, height of the conical heap that's equal to 24 centimeters. We have to find its radius and slant height. So let's start with the volume of bucket first. Volume of the bucket that would be equal to pi r square h, let's call it h1 for the bucket. Volume of the conical heap that would be equal to, let's call it r2 and h2 for the conical heap. So pi r2 square into h2, let's call it r1. So r1 and h1 I have taken as the radius and the height for the cylindrical bucket, and r2 and h2 as the radius and height for the conical heap. So volume of the bucket that would be pi r1 square h1, and volume of the conical heap that would be pi r2 square into h2 divided by 3. Volume of cone that's equal to 1 by 3 pi r square h. Now we can substitute all the values and cancel out this pi from both sides. So r1 square 18 square into h1 32, that's equal to r2 square, which is unknown, r2 square into h2, which is equal to 24 divided by 3. Now we just have to calculate the value of r2. If you calculate r2, 18 square, 18 into 18 into 32, that's equal to r2 square into 24 by 3, which is equal to 8. So r2 square you will see that would be equal to 18 into 18 into 32 divided by 8. 32 by 8, that's 4. So r2 square you will get that would be equal to 18 into 18 into 4, which I can also write as 18 into 2 into 18 into 2. R2 square that's equal to 36 into 36. R2 square that's equal to 36 square. So radius of the conical heap R2 you will get that would be equal to 36 centimeters. Radius of this conical heap R2 that's equal to 36 centimeters. Now what else we have to find? We got the radius. We also have to calculate the slant height. And we know the relation between the slant height, the height and the radius of any cone. It always forms a Pythagoras theorem. Height is known to us 24 centimeters. Radius we just calculated 36 centimeters. We have to find the value of L, the slant height. We know L, that's always equal to under root of r square plus h square. So if you just substitute the values, the value of L slant height you will get that would be equal to 36 square plus 24 square. This value would be equal to 12 into root 13 centimeters. The slant height of this conical heap that's equal to 12 into root 13 centimeters, and its radius is equal to 36 centimeters.